Alright, we're going to solve a few equations here using multiplication and division. So let's go ahead and solve a few here. Let's see. First question we're going to take a look at, we're going to say that we have x divided by 2 is equal to negative 8. So the key here is to realize that we are dividing the x by 2, because we always want to do the opposite or the inverse of what's happening to our variable. So since I'm dividing by 2, I'm going to do the opposite and multiply by 2. Alright, now when I multiply a whole number times a fraction, I can think of this whole number as a fraction by putting a 1 underneath it, and we can also remember that there's a 1 in front of that x. So now I'm going to multiply 2 times 1x gives me 2x, and 1 times 2, which is 2. My equal sign is just going to come straight down, and I have negative 8 times 2, which is negative 16. Alright, the next thing I'm going to take a look at is that we have now a 2 divided by 2 right here, so I can actually cross that out because 2 divided by 2 is 1. Alright, so my final answer is that I have 1x, which is equal to negative 16. Alright, let's solve another one here. Let's say we had 9 is equal to y divided by negative 3. Well, in this case, I'm dividing my variable by a negative 3. The opposite of dividing is multiplying, and I'm going to multiply by negative 3. And the reason I'm multiplying a negative by negative 3 is that a negative divided by a negative is going to give us a positive. That's what we want. So over here I'm going to put times negative 3, and we'll see that these 3's cancel each other out. If you don't see that, you can always multiply negative 3 and 9 and get negative 27. You can multiply this 1y times negative 3 to get negative 3y, and then take this negative 3 right here and just bring it along for the ride. And then at this point you see that negative 3 divided by negative 3 gives you that 1 that you need. So we have negative 27 equals y, and I'm going to write it with the variable on the left and say that y is equal to negative 27. Alright, let's do a third problem here. This time we have c divided by 5 is equal to 0, and since I'm dividing by 5, I do the opposite, which is multiplying by 5. Can make this 5 over 1 if I want, times 1c over 5, which gives me 5c over 5 equals 0 times 5 is 0. Those 5's cancel each other out, and I'm left with c is equal to 0. Alright, so we're going to take a look at a couple problems now where I am dividing to solve the equation. So the first equation I want to look at is 4x is equal to negative 16. In this case, I'm multiplying 4 in my variable because they're smushed up next to each other. So I'm going to do the opposite of multiplying, which is dividing both sides by 4. 4 divided by 4 is 1. So I have 1x, which is equal to negative 16 divided by 4, which is negative 4. Now let's say, I didn't check any of the other ones, but let's say I did want to check. So you write the word check to show that that's what you're doing. You'd write your original equation, and you substitute in what you thought the answer was, negative 4. And then you see if that works. 4 times negative 4, that works. That's negative 16. And that's what we want it to be. So we're good. We know we did the right thing. Oops. Let's do this. There we go. Alright. do this. Alright, let's solve two more of these equations then. So we have negative y is equal to 12. In this case, we want to realize that there's actually a negative 1 in front of that y. So when I divide both sides, I'm going to divide both sides by negative 1. Okay? Negative 1 divided by negative 1, those cancel out, and I'm left with y equals 12 divided by negative 1 is negative 12. And our last problem here, we're going to say that we have negative 20 is equal to negative 5b. Since b and negative 5 are being multiplied, I do the opposite and divide. Negative 5 is reduced to 1, so I have a b over here. And on the left, negative 20 divided by negative 5 is 4. I always like to put my variable on the left, so my final answer is b equals 4.